In order to determine the largest force P that can be supported before any of these two members fracture, whereas the material properties are given from our stress strain diagram, where we are given two graphs, one for compression and one for tension. From it, we can extract out the maximum stress the member can sustain in compression mode as well as in tension mode. So to start, first of all, let's develop our free body diagram, selecting joint B and applying all the external loads and the internal forces that will be generated in the two members. So in order to develop the free body diagram, let's put our axis at point B, and then I have a vertical load of P acting downward, whereas we will have an internal force in the member CB given as FCB going away from point B. That is indicating that we are assuming that the force is in tension. Similarly, in the member BA, we have directed the force going away from point B. That is assuming that the force is in tension. Moreover, since it is at an angle and we are given the height of 3 feet and the horizontal distance of 4 feet, so we can form our right angle triangle, and the hypotenuse of that right angle triangle will be 5. Next, once we have the free body diagram, let's apply our equilibrium equation, starting with summation of forces acting along the y direction equals to 0. In this case, I have an external load of P going downward. That's why I have a negative value, whereas the force FPA will also have a component in the y direction going downward. So it can be calculated as 3 over 5 times FBA. Simplifying, we get our value of FBA equals to negative 5 over 3 times P. Here, the negative sign is indicating that the direction that we have picked in our free body diagram, the internal force is actually in the opposite direction of that. Since in our free body diagram, we have selected the force going in the tension, but in actual case the force in is in compression, so the magnitude of the force will be equals to 5 over 3 p. Now this is an important step. We need to identify which of the members are in compression and tension, because we will be comparing it from the stress strain curve of compression and tension. Next, let's go ahead and do summation of forces along the horizontal x direction equals to 0. In this case, I have a force FBC going towards the left, whereas a component of FBA will also be pointing towards the left. So simplifying, we get our value of FBC equals to negative 4 over 5 times FBA. Now from the above equation, we can plug in the value of FBA and simplify. So the internal force in the member BC is coming equals to 4 over 3 P. Now in this case, since it is a positive number, meaning that the force in member BC is in tension. Now, once we have identified the internal forces in the members, next let's figure out what's the maximum value of P at which these members will start failing. So let's assume the failure in member CB first and calculate the value of P. Now to do that, we have to calculate the value of a stress that is generated and compare that value of a stress with the maximum tension this material can sustain. So since in tension mode, the maximum is stress at which the failure takes place is 5 ksi. So let's compare that with the internal force given by our formula of stress is equals to force over cross-sectional area. So we have a stress value of 5 ksi, force is 4 over 3 p that we have calculated, and the cross-sectional area is given to us in the problem, that is 4" square. Simplifying, we get our value of p equals to 15 kip. Next, let's assume that the failure happens in our member BA and identify at which specific value of P that failure will take place. Again, coming to our stress strain curve, in the compression mode, the failure happens at 25 ksi. So let's put in the value of stress equals to 25 and compare it with the force over cross-sectional area of the member BA. So here we have 25 equals to 5 over 3 P, that is the internal force in member BA, divided by the cross-sectional area given to us, that is 1.5 inch square. Now simplifying, we get the value of force is 22.5 kilopounds. Now once we have the value of force at which each one of these members fail, next thing is to determine the largest force P that can be supported before any of the member fracture. In this case, the controlling force will be the smallest value, because once you start applying a force of 15 kip, our member CB will fracture.